Good day, viewers, and welcome back to my YouTube channel. I remain myself. Akinyemi Oluwaseyi Jeremiah is my name, popularly referred to as Medic Adonai. I'm presently an undergraduate of the then University of Sokoto, now known as Usman Danfodio University Sokoto. I'm presently studying medicine and surgery. And I would like to welcome you back officially to my YouTube channel. Like we all know, the only thing we do here is learning, and that is what we'll be doing today. In today's class, I'd like us to look at stochiometry. Stochiometry. Before I proceed, here is my number for those who would like to message me after the class or maybe private tutorial or whatever. I also have a tutorial, an online tutorial that I run, and if you would like to be part of our students, you can let us know. Just message me using this number. Message me through this number. Alright, so we're talking about stochiometry. Now when we say stochiometry is just the quantitative aspect of chemistry. Just like when you say, okay, I want to prepare 1 derica of rice. I'm sure many of us are familiar with the word derica. 1 derica of rice. Now I want to prepare 1 derica of rice. There is a quantity of salt I need to add to that 1 derica of rice. And if I want to prepare 2 dericas of rice, or 5 dericas of rice, there is also a quantity of salt that I need to add. For example, if I want to prepare 1 derica of rice now, I may need to add 2 spoons of salt. That means if I am preparing 5 dericas of rice, I will need to add 10 spoons of salt. That is what stochiometry is all about. That's just what it's all about in chemistry. If I want to prepare 1 mole of water, how many moles of oxygen will I use? Now, if I want to prepare 55 moles of water, how many oxygen moles will I need? That's just what it is. So that's what we'll be looking at today. We'll be looking at stochiometry under different headings. And I would like us to start with mass. The mass stochiometry, or we say mass to mass, or we say mass stochiometry. Okay, now let's do this. Calculate the mass of potassium chloride. That would be produced if 25 grams of potassium chlorate are decomposed. Now, the question says, calculate the mass of potassium chloride that will be produced if 25 grams of potassium chlorate are decomposed. Alright, it's a very easy something, but there is something I want us to know about stochiometry. When you are giving questions to stochiometry, the first thing I would like you to always do is to write out your equation. Now they said the mass of potassium chloride that will be produced if potassium chlorate is decomposed. Now, this is our solution. Now, potassium chlorate, KClO3, when it decomposes, it gives us potassium chloride plus oxygen gas. The next thing is for us to balance this equation. This equation is not balanced yet. So we need to balance the equation. Now, if we are to balance this equation, okay, we can put 2 here. We put 2 here and we put 3 here. 2 of this, 2 of this, 2 of this, 2 of this, and 6 of this. Yeah, this equation is balanced. This equation is balanced. Now, anytime you are giving a mass to mass stoichiometry, please calculate for the relative atomic masses of the two compounds involved. Now, we should calculate for the mass of potassium chloride. Now, that's to tell us that potassium chloride is involved here. In our calculation, we need to involve potassium chloride. Now, the side of potassium chloride that will be produced is 25 grams of potassium chlorate. Okay? Potassium chlorate is also involved. Now, so we leave oxygen out of our calculation because it was not mentioned. So we leave it out of our calculation. Now, let's calculate for the relative atomic masses of KCl in this place and KClO3 in this place. Now, we know that we are dealing with these two now. Okay, let me erase this because this is the balanced. This is the balanced equation. So we make use of the balanced equation. But I just want us to know the one we are working with. Okay. Now we have this to be. Okay, let's approximate this to 40 plus this. No, let's leave it as 39. 39. Now this is 35.5. 35.5. And this is 16 times 3. That is 48. K, Cl, and O3. Those are the three elements we are calculating for in this compound. We have 39, we have 35.5, we have 48. Alright, let's add together 39 plus 48 plus 35.5, 17 plus 5. We have 2 here. 17 plus 5, okay, that should be 22. Then 5 plus 4, that's 9. 9 plus 3, that's 12, that's 122.5. But we are having 2 moles of KClO3. So it will be 122.5 multiplied by 2. So if we multiply 122.5 by 2, we have this. So we have 245.0. So we know that this one is 245. This side will be having 245. $245 on this side. 245 grams of KClO3. Now, let's calculate for this also. We have 39 plus 35.5. So we have 4, we have 1, we have 74.5 times 2 also. We have 0, 1, we have 9, and we have 14. So we have 149. We are making progress. We have 149 for KCl. Alright. So we can say 245 grams of KClO3 gave us 140, is it 140? Yes, 149 grams of KCl. Now, they said we should calculate for the mass of of potassium chloride that will be produced if 25 grams of potassium chloride are decomposed. Now, we already know that we are doing a mass-to-mass calculation. So we need to calculate for the relative atomic masses, which we have done now. The relative atomic masses of our two compounds involved. Now, the next thing for us to do now, they said if 25 grams of potassium chloride are decomposed. So, since 245 grams of KClO3 is giving us 149 grams of KCl, that means 25 grams of KClO3 will give us X. As simple as that. Then we cross multiply. When we cross multiply, we have 25 times 149, giving us 245x. So 149 times 25, 5 times 4, 5 times 9, 45, 5 here, 4, you have 2, 7, 9, 2, 5, we have 7, 1, 3, 7, 2, 5. Yeah. So on this side, sorry, I'm not using my calculator. We have 3725. 3725 equals to 245x. Then divide both sides by 245. So when you divide both sides by 245, 245 will cancel 245 here. So your answer will be this divided by this. So what you get when dividing dividing 3,725 by 245 is your final answer. So that is for mass-to-mass stoichiometry. I hope you understand this. Alright, we move into another sub-heading or another part of stoichiometry. Stoichiometry is not something difficult. Many people see it as, many people I've heard from many people that stoichiometry is not difficult, but it is kind of tricky. But I don't think it is tricky. It's just once you understand the concepts behind stoichiometry, you are good to go. Alright, now let's look at volume to mass. Volume to mass, or mass to volume. Mass to volume calculation. Alright. Calculate the volume of carbon dioxide gas that will be produced from 112.5 grams of 3 oxide at STP. We have our equation to be this. Giving us 2 of Fe plus 3CO2. Okay. Now, this is also very simple. Now, we are looking at a mass to volume stoichiometry. Now, just like in mass to mass, we did relative atomic mass to relative atomic mass in the first place. Now, for mass to volume, we'll be doing relative atomic mass to our standard volume multiplied by our number of moles. I'm going to explain that. Okay, now, is that we should calculate the volume of carbon dioxide gas. Okay, carbon dioxide gas is mentioned. And carbon dioxide in this equation, this is carbon dioxide. Carbon dioxide is having 3 moles. Now, that will be produced from 102.5 grams of iron 3 oxide. Now, this is iron 3 oxide. Iron 3 oxide here is having just 1 mole. There's an invisible one here. We know that in mathematics. Okay. Now, let us say this is what we are working with. This is what we are working with. It's very important to know what you are working with, so that you not just be calculating for everything, something you don't really need. This is what we are working with here now. Alright. Now, since we are given gram of iron 3 oxide, so we are in this place we are talking about mass. We are talking about mass here. So we need to calculate for the relative atomic mass of this. Now, they said we should calculate for the volume of carbon dioxide gas. Carbon dioxide gas. Now, volume is what we are using here. So, we are calculating for RAM in this place, in the first line, because we are giving gram, but we are using our standard volume, which is 22.4 liters, or DMQ. DMQ is also equal to liters, multiplied by 3. Because we are having 3 moles here. That is in our first place. Now let's do that. Let's do that. Coming. So we are having 56 for iron. 56 times 2. That will give us 112. Now plus 48. So 112 plus 48. Oxygen is 16. 16 times 3, that's 48. So that's how I got 48. So I'll be having 0, 1, 6, 160 in this place, 160 in this place, 160. Then for this 22.4 will give us 67. I mean 22.4 times 3, because we are having 3 moles here. Remember I said we are multiplying the standard volume by the number of moles that you are having. If you are having 4 moles here, it will be 22.4 times 4. But we are having 22.4 times 3. That will give you 67.2 dm cube or liters. This one is gram. Now, very simple. Then bring your 102.5 grams of iron 3 oxide. Bring it here. 112.5 grams. Giving us. Now, they said we should calculate for the volume of carbon dioxide. So this place will be X. As simple as that. Then we cross multiply. Here we'll be having 112.5 multiplied by 67.2, giving us 160x. Whatever we get here. Let's say we after calculating we got 6,500 here equals to 160x. Just divide both sides by 160. 160 cancels 160. 60,500 divided by 160 will be our answer. But that is, I'm not saying 6,005 is our answer for this. Just calculate it so that it won't take much of our time. So this is just our final answer. This times this, what you get divided by 160. That's your final answer. Alright. We'll move to another heading. Move to another heading. Alright. Let's look at mole to mass. Mole to mass. Mole to mass. Please, any stoichiometry question you are given, make sure you know the type of question it is. Whether it is a mole to mass stoichiometry, or mass to volume, or mass to mass, or volume to volume. It can be mole to mole, it can be volume to volume, it can be mass to mass, or anything. Alright, like we said, how many moles of KClO3 will decompose to produce eighty grams of oxygen gas? How many moles will decompose to produce 80 grams? Gram is mass. Automatically, we should be able to deduce from this that we are talking about mole to mass calculation, or we call it mass to mole, but mole to mass is okay. Alright, like I said, you have to balance your equation. He said how many moles of KClO3? When KClO3 decomposes, you have KCl plus O2 and 2, 2, 3. Now, these numbers at the front that are studied as coefficients are the moles. And they are the moles of these compounds. So that's what we call moles. Don't mind my handwriting that is moving towards the... Okay. Now, he said how many moles of KClO3? That means in KClO3, we are dealing with moles. We decompose to produce 80 grams of O2. That means in oxygen gas, we are dealing with mass. Please take note of that. Now, in the equation, in the balanced equation, 2 moles of KClO3 gave us. Now, I told you that when you are dealing with mass, you first calculate for the relative atomic mass of that given compound or molecule in the first line. Now, if you look at in this place, we are having 3 of oxygen gas, we are having 2 of KClO3 here. Now, if you have to calculate for 3 of oxygen gas, oxygen is 16 times 2, 32. 32 times 3, that is 96. So 96 grams here. 96 grams. Now, if 2 of KClO3 produces 96 grams of oxygen, that means the next said how many moles of KClO3? That means the number of moles is what you are looking for will be produced from 80 grams of O2. As simple as that. You see, the only thing about stoichiometry is you interpreting your questions. And once you are good at interpreting your questions, it's not a big deal. The next thing is just for you cross multiply. So you'll be having 2 times 80 giving us 96x. 2 times 80 is 160 divided by 96. Divide both sides by 96. So your x will be equals to 160 divided by 96. Alright, let's look at volume to volume. Yeah, volume to volume. We have volume to mass, volume to volume, volume to mass, volume to moles, mass to mass. I said this earlier. So we'll be looking at volume to volume now. Volume to volume. Volume to volume. All right. Sorry, volume to volume. What volume of ammonia gas with that with 22.5 liters of oxygen gas. Now we are having 4 which is 302. All right. Now our question says, what volume of ammonia gas will react with 22.5 liters of oxygen gas? Okay, we are dealing with volume. They say what volume will react with 22.5 liters. You know when we say liters, dm cube, cm cube, we are talking about volume. All right, so we know we are dealing with a volume to volume something. Now, what volume of ammonia gas? Where is ammonia gas here? This is ammonia gas. We are having 4 moles of ammonia gas in this place. We react with 20.5 liters of oxygen gas. Where is oxygen gas? This is oxygen gas. This is ammonia gas reacting with oxygen gas. You know, if it was in this side, you say we produce. They said we react. So in this side, we have 3O2. 3 moles of ammonia of oxygen gas. Now, I said something the other time. When we are calculating for volume, your first line of that your equation, it will be your mole multiplied by standard volume, which is 22.4. Now, we are calculating for, we have volume here, we have volume here also. So, it will be 4 mole times 22.4 and 3 times 22.4. So, 4 times 22.4 will give us 89.6 liters. In this way, we are having 67.2 dm cube. I intentionally wrote liters here and put dm cube here, so as to remind you that your liter is equal to dm cube. So what volume of ammonia gas? This is the column for ammonia gas. So ammonia gas is what we are looking for. The volume of ammonia gas is what we are looking for, which is X. The last said we react with 22.5 liters. We react with what volume of this? We react with 22.5 liters of oxygen gas. As simple as that. Just cross multiply again. So you'll be having 89.6 times 22.5 equals to 67.2x. What you get here, let's say you got 1,000 here. Let's assume. Now, you're having 67.2x here. You just divide both sides by this, and you get your final answer. But this is not our answer. So this is where I will be stopping for today. I'm very sure you find this class not only interesting but um, benefiting. I'm sure you'll be getting more of this subsequently by the grace of God. I remain Medic Adonai. For those who would like to join our tutorial class for the next UTME preparation, this is my WhatsApp number. Let me write it boldly here. Here is